Okay, for my next review, I'm looking at an animation by McGraw-Hill. Assume it's part of their textbook supplement back in the day. I believe they have some newer ones, but these are the ones linked from our site, so we'll take a look at them. We'll start with the Punnett squares here and take a look at it. Each of these have some post-lab quizzes, which are a great resource, as well as some instructions that come out as Word documents. But we'll go ahead and actually take a look at the lab. This one's pretty basic. But what it does is it gives you an introduction to Punnett squares. There's a set of procedures and instructions over here. There's some extra information if you need it that comes up, which is all helpful. And the instructions are you click on the TV VCR, which if nothing else betrays its age, this does. But you click on it and it gives you a description.
This Punnett square predicts the result of a cross between two heterozygous tall pea plants. Each gamete carries only one of the two alleles that controls height in pea plants. The alleles from one parent are written over the top boxes of the Punnett square, and the alleles of the other parent are written to the left of the square. To determine the possible genotypes of all offspring, each box is filled in with the alleles to the top and the left side of that box. Each box then contains two alleles, one possible genotype. You can see that there are three different possible genotypes and yet only two possible phenotypes.
And that's it for the instructions. You can close on that, and then if you follow along, it tells you to open the workbook and go through your own process. So here we are. And here it tells us to cross a homozygous long-winged fly with a homozygous vestigial winged fly. So we'll go ahead and do that. So for the first parent, we'll go with a homozygote one characteristic. And for the second one, we'll go with the homozygote recessive. And we can check our parents by, let's move me over here. We can check our parents here, and it looks like I got the right parents. And so from these, we'd end up with one showing the dominant characteristic here, one showing the dominant, and then we get recessive. Let's get one wrong just for fun. And we'll check our offspring.
Examine the parents' alleles to determine the offspring they are expected to produce. Then try again.
So it lets us know that we're doing some of this wrong, which is always nice. So here this should be a heterozygote, so we should change this one out and put in the heterozygote here. And so I guess we should have all heterozygotes, and now we're good. So we'll check our offspring.
Fill in the rest of the Punnett square to determine the expected genotypes and phenotypes of all the offspring.
And it lets us know that we need to do that. So we drop in the offspring genotypes and then say check offspring, and it beeps at us correctly. So looks like we pulled that off. There's some other things I guess we can do here with a table and a journal and a calculator. That's helpful. We can actually close this scenario here. I think this is good. It certainly is old, and I think students lose interest really quickly. Some of the things, it's a little cumbersome when you're clicking on the different things. If you get it wrong, it's not quite clear what you're supposed to do. I could envision as a teacher walking around a lot trying to explain the logistics of this rather than explaining some of the science behind it. So I could see some challenges there. I also think it in the descriptions, it doesn't do a great job of describing what it is to be a heterozygote, what it is to be homozygous dominant, what a phenotype is, what a genotype is. Those things are missing from the lab. It's just doing the Punnett square. And I think it's also missing some of the added components of looking at probability and percentages and so on, which would be neat to talk about too. So again, I guess I'd steer away from this with my students. I just don't think it has quite the pizzazz that one might want. But it is a way to go through Punnett squares if you, in a distance learning environment where we wouldn't have another way to do it.